All right, so yesterday's assignment, you got a new assignment, which is your first review. That first review that you got today, that's from the textbook. There are a couple of numbers on it that I want you to go ahead and cross off that you don't have to do. So on both sides, 14 through 20 are not things that we covered because they're not in the curriculum. So first off, on review that you got today, not last night paper, but the one I just passed out. Cross off 14 through 20 on both sides. Don't have to do those. Also, the one that says bonus, again, it's not really bonus, it's just a homework assignment. But the one that says bonus on the first side, the one that says Form 1, that one you can also cross off. So 14 through 20, and then also the bonus on the first side, on the back side, 14 through 20, you can cross off. The bonus on that side you could do, but that's for tonight's assignment. So make sure you try those. Tomorrow we will spend time going over that review. So make sure you tried it. If you have questions, come with those questions. That's over everything that we talked about from the beginning of Pythagorean theorem to the converse of that Pythagorean theorem, triples to geometric mean, right triangles, and then trig with SOHCAHTOA ratios. So again, make sure you try those and then come with questions tomorrow. I will also give you a second review to do over the weekend. The one I give you over the weekend will be the one that looks like it's handmade by me and will be more similar to the actual test itself. All right. And then I'll go over that one with you guys on Monday, and your test is on Tuesday. All right, for the homework from last night, I'm going to try and go through these as quick as possible. On 1 through 4 up here at the top, we got all we have to do is label angle of depression, angle of elevation. That's all they wanted us to do. So angle of depression in the first figure, depression is going down from a horizontal, so it's the one over there by the helicopter. So how could I name that angle? FLS, that works. Angle FLS. All right. Angle of elevation is going to be what? So it'll be what? So that was depression. Now elevation is going from a horizontal up. So that's angle what? So you could say it a couple different ways, but LST or TSL, that works. Did I have any 3 letters on these? No, on this one I could have just done the 1 letter for the vertex because there's only one angle coming out that vertex. So if I wanted to call the angle of depression just angle L, that would have been fine. Or angle of elevation, angle S, that would have been fine. Because again, there is only one angle drawn. On number 2, we have ourselves a Ferris wheel. Again, angle of depression going down from a horizontal. So what's the angle of depression here? R2W. Angle of elevation, SWT. On number 3, angle of depression, ECB works. And angle of elevation. So angle of depression on this one was the one coming down from horizontal top. Yeah, if you just want to call it angle C, that's fine too. Angle of elevation on this one, ABC, or here, I'm just going to label it 1 this time. Angle B, the only angle, so I can just use that vertex. All right, on the next one, number 4, angle of depression. Angle of depression is coming down from the balloon there. All right. Angle of elevation. RPZ. And again, I could just use the middle vertex there. I wanted to. Any questions on those? All right. On number two, sorry, number five, on a mountain bike trip along the Gemini Bridge Trail in Moab, Utah. Now, they give you this whole explanation. You're basically, there's a canyon, you're on the floor of the canyon, you're looking up at the natural bridge, and they want you to find the angle of elevation to the nearest tenth of a degree. Do they give you a diagram? No. So if you don't have a diagram, what should you do? Draw one. So again, it doesn't have to be an awesome drawing. There's my cliff with my canyon. Here's my person standing down at the bottom of the canyon. And they're looking up at the top of the canyon. All right. Now, they gave me a bunch of stuff that I can label. So it said he is standing 60 meters from the base of the canyon cliff. The natural bridge is about 100 meters to the top. The line of sight is, sorry, her line of sight is about 5 meters above the ground. So they gave me these measurements. They want us to find the angle of elevation. Well, angle of elevation from her eye level is right here. My right triangle is not starting all the way at the bottom. It's starting from here. This is my right triangle. So when I do this problem, the distance she is from the cliff is still 60 meters. But what's the height that I'm going to use in that triangle? What was it? 95. Because I have that 100 for the entire thing minus her height. So that side is 95 meters. Now we can go ahead and set this up. So we have so X, that's the angle I'm using. What two pieces do I have? Opposite and adjacent. I don't know why they really like using tangent on this one. So the majority of the problems on this worksheet did use tangent. There's probably, I don't know, there's about 3 or 4 problems that weren't tangent. All the rest were tangent. So they didn't do a whole lot that weren't tangent. On this one, we have our opposite and adjacent. Opposite and adjacent and is tangent. So we're going to set this up. Tangent of our angle measure, which we don't know, that's what we're looking for, is equal to opposite over adjacent. So 95 over 60. We need to get rid of tangent. Well, how do you get rid of tangent when you're solving for an angle measure? That's where we do the inverse. So we can do the inverse tangent. 95 over 60. And when we do that, we should get an answer that is approximately 57.7. Again, that's in degrees because it is an angle measure. Again, they told you on each round what they wanted you to round to. So make sure you pay attention to all the rounding directions. On 6, got a little bit easier because they drew the diagram for you. All right. This one, we already have our diagram. We have the angle measure. We know that we're solving for this piece. We have a question mark there. I'm going to change it to an X. We have the height of the building was 35. We have enough to solve for this. So based on the angle, what pieces do we have? Well, this is adjacent. This is opposite. And again, we are doing tangent. So tangent of the angle is equal to opposite, which is 35, over the unknown value of X. We need to get X by itself. So first thing we're going to do, multiply X to the other side. We have a denominator. We have X times tangent of 60 equals 35. How do I now get X by itself? Divide. So I need to divide off tangent of 60. So X, a missing piece there. I plug in 35 divided by 360 into the calculator, and we get roughly 1.2 feet. Again, you have to round. Now, 7 was the one that yesterday I said you could skip. You do not need to do 7. If you want to know the answer to 7, I'll go ahead and write down. I'm not doing that one because it's not something you really need. But the correct answer is 50.1 feet. On number 8, they gave us the whole triangle that we needed. Now, yeah, they wrote out in words what they want us to find. They want us to find how far is the whale from his binoculars. So that's what we're labeling as X. Now, they gave us an angle of depression. Is the angle of depression in the triangle? No, it's not in the triangle. So what we could do, since they gave us the angle of depression, is also write in the angle of elevation. Because depression and elevation are always going to be the same. So on here, this is 20. And now that I know I'm using that piece, label my diagram accordingly. So we have, based on the 20-degree angle, I have this side over here, which I have to combine. This is 30 and 3, gives us 33. And that's going to act as the opposite side. And I'm looking for the hypotenuse. So which one uses opposite and hypotenuse? Which ratio uses opposite and hypotenuse? Sine, right? So sine of my angle, 20 equals opposite, 33, over the hypotenuse, so that's multiply x to both sides. We end up with x times sine of 20 equals 33. Now, to get x by itself, you got to undo that operation of timing sine of 20. So divide sine 20, divide sine 20, and x in this one, or missing piece, we were selling for, was roughly 96.5. Now, before I move on from this one, I do want to show real quick, we did have other options, all right? So I like setting it up this way. We have 20 here, so I know that the other angle of elevation also had to be 20. We could have looked at these two angles together. This is making a right angle as well, right? Do we know this angle? Well, if that's 20, that'd have to be 70. If I use that angle instead, I would have had adjacent and hypotenuse. So I could have also set this up as a cosine problem. So then cosine of 33 over x. All the work is pretty much the same. I've just been using cosine instead of sine. I get the same answer. And again, one of the reasons I get the same answer, if I did it that way, is here we have sine of 20, here we have cosine of 70, 20 and 70 add up to 90. Sine of one angle is equal to the cosine of its complement. Again, it doesn't matter which one you use, whatever angle you use, you'll get the same answer. And the sets are pretty much identical. Any questions? Let's move on to the next one. All right. On the other side here, start off pretty much the same way. Actually, it's up just a little bit. All right. On 1, 2, we're doing the same thing that we were doing on the previous page. So angle elevation, angle depression. This is depression, this is elevation. So angle of depression, angle R, angle of elevation was angle, sorry, right, Z, instead of angle. Angle Z. Over here, same thing, angle of depression, angle R, angle of elevation, angle M. Number 3, do you have a diagram? No. So what should you do? Make one, yeah. All right, so water tower. We have and that, we got line sight down to the person that was looking at it. Have distance they were from it. What did it say? 100, I think. No, 110. Okay, so this is 2.5 feet tall. Person was 6 feet. Now, do I have a triangle right now? Not exactly, but if I just draw a horizontal line here, this is the right triangle that I need. Now, I have this distance is the 110. I have this entire height of the entire water tower was 32.5. I need to subtract off the 6. So this is 26.5 feet for this side of my triangle, right? Again, that's the piece I'm using. I'm not using the whole thing, just that part of it. And they wanted the angle of elevation. So that's gonna be my X. Like I said earlier, there's a whole lot of tangent in these problems. This one is again tangent because we have opposite. Opposite over here. This is adjacent. So tangent of X equals 26.5 over 110. We're solving for an angle. So we're doing the inverse operation. All right, so we got inverse tangent of 26.5 over 110. You're plugging it into the calculator and you should get 13.5. That's our answer for number 3. Number 4. Again, do they give you a diagram? No, no diagram. No, draw one. Here's my building. Oh no. Building, there's a roof, and there's a ladder. So there's my triangle, round, the ladder, and the height of the building is making a right triangle. So now, they gave us the height here was 30. 30. They said that, let's see, tell us. The angle of elevation is 55 degrees. They wanted to know how far the ladder was inside the house. So, we have opposite, we have adjacent, and again, create another tangent. So, tangent of 55 equals 30 over X. Multiply X to the other side. Tangent of 55 equals 30. Divide off tangent. 21 feet. It says round to the nearest foot. Again, make sure when you're typing this into the calculator, you're getting the correct answer. You want to practice typing these in. Is half of getting these right is making sure you type it into the calculator correctly. If you type it in wrong, you won't get the right answer. So make sure you practice typing each of these in. Any questions there before I do this up? All right. The next two, well, again, this one is the one I say you can skip, number 6. So we only have 5 and 7 left. On number 5 and 7, they give us the diagrams. On 5, they say that's a flagpole. It needs to be less than 25 feet. It talks about how high her eye level is. That's already labeled. It tells us how far away from the flagpole we are. That's already labeled. It tells us the angle of elevation from her eyesight is 25 degrees. They want to know the entire height of the flagpole. Well, right now, the right triangle that we have is here. So the piece that I can solve for right now is just this height. I'm going to actually call that y instead of x for right now, because we're not solving for x right away. We have to solve for that missing piece first. Well, we have opposite. We have adjacent. Adjacent. So this is hypotenuse. Sorry, not hypotenuse. Opposite and adjacent is tangent. Again, tangent of the angle equals opposite, which we call y for now, over hypotenuse. Sorry, over adjacent, which was 36. On this one, we get to just multiply by 36. Times 36 to both sides. We already got x by itself. When you do 36 times tangent of 25, now you don't get your final answer right away. You get, I think it was 16.3. No. 16. I think it's 16 point something. But that's not the final answer either. 16.8. All right, so we get 16.8, but we need to add this piece to find the entire height of the flagpole. So we have the 16.8 plus 5.5 gives us a total of, that's 3, carry a 1, that's going to be 22.3, right? The 22.3 feet, again, minutes. That's the height of our flagpole. Is it in compliance? Yes. It's less than 25. All right. Like I said, 6 was one I told you could skip. 7, there's actually 2 problems that you have to do here. So we had Mr. Dominguez up here on the top. So this total length here is 46. You have this triangle. So there's a dog here, and there's another dog over here. They want the distance between them. Well, first, we're going to have to solve for 2 separate triangles. We have that triangle, but then we also have this triangle. So we can solve for each of these 2 pieces separately. In both scenarios, we are going to have the same 2 pieces. They gave us these angles at the top that were at angle depressions. We can put them into these 2 triangles here. So this one was 34. The other one was 48. So we have our angle of elevations now. we label them accordingly. This is opposite. And then these two are to adjacent sides. So both times you're using tangent. Both times the setup is exactly the same. So let's set up the first part of it. For the small triangle, have tangent of 48 equals 46 over x. We need to solve. X over, I'm multiplying it. X times tangent of 48 equals 46. Get rid of tangent of 48 by dividing it off. So 46 divided by tangent of 48 gives us 41.419. The other one is essentially the exact same thing. Instead of going all the way back to the beginning, what values am I going to have to replace? Well, the 48 becomes a 34 and the x becomes a y. So I'm just going to skip down to this very last step. For y, I'm going to do the exact same thing. So 46 stays the same. The angle measure is what's changing. So tangent of 34. So I just replaced the x with the y and replaced the 48 with the 34. The setup was exactly the same. So there's no reason to go back through all those steps. 46 divided by tangent 34 is 68.1978. We need to find the difference between those. So if we subtract those two from each other, it said round to the nearest root. So we get 26.778. We can round that off to 27 feet. That's our answer. Found x, found y, then we do the difference. We get the distance between the two dots. All right. Your assignment, again, is that review. I want you to try all the problems except for the ones I told you to cross off at the beginning. Again, it's on 1 through 13 on both sides. On the back, you can also do the bonus. Underneath it. You have a total of 27 problems on that review. Again, it's going over everything from the beginning of the section to the end. Yes. Which game? Basketball. This is district. When did I mean soccer was already from district. So I don't know. I can't say yes. But it's no pressure. Right now, I feel like going taking a nap. Just take a nap and come back at 7.